Hi, Mr. Lee here. Let's get some domain and range practice. Okay, so you'll see a variety of different examples here. Remember that domain is the set of all your x values, and range is the set of all your y values. Okay, so here's the first question. What's the range of this function called h? Okay, so this function is just a list of, just 5 separate points. Okay, so automatically you should be thinking either A or D because you're listing out specific y values. Okay, the second you have an inequality, that means you're communicating infinite values, which means your graph would be connected in some way. But these are separate points, so we can already eliminate options B and C. Okay, but let's read these y values. We're asked to find the range. For y values, you're going up and down. So I like to look at the bottommost point and then just kind of work my way up. Okay, so here's my bottommost point. I'm only going to focus on the y values. The y value here is -3. The y value here is -2. The y value here, +2. These two share the same y values of 4. So all the y values I just listed should be option A. Okay, you're only focusing on the y values for range. So let's click that, press check, see some other examples. Okay, what is the domain? All right, so check it out. We are connected, right? You have 2 endpoints on left and right, but you're connecting the points all the way through. So that means we have infinite points. So I can eliminate options A and D now because they're only communicating what, 5 x values here, 5 x values here. I need to communicate infinite x values because I have infinite points because of this connection. Okay, so let's see what our endpoints are. Domain, set of all x values. I'm going to look at my leftmost point, which has an x value of -7, and my rightmost point, which has an x value of +7. So I need to have x values communicated between -7 and 7. We're going to look at this compound inequality. Okay. So that gives you a good example of domain and range, both separate points but also connected. We also have a GimKit practice here that involves some of your infinity concepts, right? So here's an example of a graph that goes forever to the right, and it also goes forever up. Okay, you're assuming this arrow is also going forever up and right. This arrow is going forever forever right and down. Okay, so we're asked for the range. We're going to focus on the y values, up and down. So I'm going to find my bottommost point, which is here. But because we're assuming it goes forever down, that means we have a negative infinity. Okay, so already this should be my answer because we want range y values, negative infinity. But let's just make sure we understand the rest of it. My highest point is here, and we're assuming it goes forever up. We have all these points in between, so it starts at a negative infinity with the down arrow, all the way to a positive infinity with the up arrow. Range y values. Okay, here we have a discrete graph, separate points. We only have 5 points, right? We want the range again. We're only going to focus on the y values of these points. These 2 bottom points, they share the same y value of 0. These 2 points share the same y value of 3. This point has a y value of 4. So range 0, 3, 4. Don't confuse it with this, right? This is going to communicate infinite points, which means this would have had to have been connected. We just want separate points. Only 3 possible y values that you see, 0, 3, 4. Okay, let's just do one more. We have a table. What is the range? So we're getting a lot of range questions, but if you're asked for domain, you're just focused on the x values. Okay, range is y values again. I'm going to look at the outputs, 5, 1, and -3. It's got to be this one. Okay, I only see 3 points, 3 ordered pairs here, so I should only be seeing 3 y values, -3, 1, 5.